Hi. Today in this tutorial we'll learn a machine learning program uh, which using sklearn package. For this example, we'll take a tabular data and this will be a classification problem. So let's see how to install the sklearn package. We should run this command pip install sklearn. In my system it is already installed, so requirements are already satisfied is displayed. So once this is installed, uh, I'll take an example of a existing data set. This is part of sklearn package. So what this data set contains is four different types of features and one label. So this is a classification problem. So there are three types of iris flowers which are uh, classified in this problem. Uh, the so it is the classes are named 0, 1 and 2 for this demonstration purpose, and these are the different features based on which the classes will be defined. Say what this means is if the sepal length is 5.1 and the width is 3.5 and petal length is 1.4 and petal width is 0.2, this will be classified as class 0. And similarly, all these are classified as class 0. Here, if you can see, this kind of the flower which has the iris flower which has features like this will be classified as class 1. And similarly, there is another class which is class 2. So let's see how we can run a program using machine learning. So I'll just briefly run through this program and explain it later. So the first part is the include part. Here we include all the required packages, and the second part is loading of the data. After this is done, with the next four lines of code, your machine learning algorithm would be ready. So in this line, we split the data set into test data and training data. Here we select a classifier, and this one line of code will do the training for the models, and this one line of code will predict the model. So now if I run the code, it says it is 96% accurate. So let's see now line by line how this code works. So first of all, I have imported the CSV file containing the iris data. So that is present here. So I have my code here and I'm loading this file, which is nothing but the one which I showed you. Once the file is loaded, all the data from the CSV is loaded into iris object. So I'm using spider editors here, and here we can visualize the contents of the data frame which is loaded from CSV file. So here you can see entire Excel CSV data is loaded into the data frame, and after this I'm splitting the data into features and labels. What this does is it takes first four columns of the data and puts it into features, and next uh, the classification, that is a label, like wow, this is what we are going to predict, uh, that is copied into the labels part, which you can see here. It consists of 0, 1 and 2. So this is the data for us, and now so we have the data. We'll be going ahead and creating a model, but how do we test it? So sklearn gives you one very good feature called train test split. That is, it will split the available data into the training data and the feature data. So here we had the iris data set had 150 rows of data. So out of the available 150 rows of data, we can split some, let's say like 20% or 15% as test data, and use only the remaining 80% to our training of the models. So with this one line of code, we'll pass the features and labels, and we say we want the test size of 0.2, that is 20%. So you can increase or decrease, or you can keep it 15%, but yeah, I kept it as 20%. Now, since this is a classifier problem, I am taking a decision tree classifier algorithm here. So this one, with this line of code, we have decided that we are going to use decision tree classifier. And once this is done, this line of code does the training part. Classifier.fit, where you have to pass the training features and training labels. So the training data has to be passed into this method, which uh, with which the classifier trains itself, or the model gets trained. And once the training is done, you are ready to predict the data. So with this, now this is where your test data, which we have split earlier, comes into the picture. So you have trained your model already with the training data. Now with the testing data which we had, we will try to predict and see how our model works. So that is what we are printing here. So now this list has all the predictions. So we can see here. So the model has predicted for, so we have seen this 150 rows of data is was split into 120 and 30. As we see here, we had 120 rows of training data since we're getting 20%, and yeah, 30 rows of test data. So now we should have 30 predictions basically. So, and the model has given 30 predictions. If you see test set, it is 0, 1, all those things. How do we validate? So we can now compare prediction one by one with the test label which we have taken earlier as in the 20%. So while comparing one by one, we can see, did it match the expected values. So for 90%, 96% of the matches of the values, it has predicted correctly. So maybe we could print prediction. So I've added a print here saying if the prediction and the test label doesn't match, then we print so that it is easier. So I ran the code, and it's for this line it did not match, and for this, hence the percentage is 96. So, and yeah, again with this one line of code we can calculate the accuracy by passing the test labels and predictions. So now what, this is like how you have predicted for the existing values. So now if you want to test by yourself randomly, say I want to pass in a value of this one, so it selects class type 1. How we could do this, so what we can do is, instead of passing in the data of we can just pass in the values manually. For that, we need to send the values like this. We'll say how much 7, 3.2, 7, comma, 3.2, comma, 4.7, and 1.4. So let's see what predicts now. We don't need all this for now because we are not, we just need print predictions. So we are expecting it to predict one, and here we go. It predicted this type of class as one. So our machine learning program first is working as expected. So instead of now, if you want have your own data, say for example, decide my mood for today. So the features would be like what time I woke up. Say if I woke up at 8 o'clock, my mood would be good. Or if I woke up at 5 o'clock in the morning, my mood wouldn't be so good. For example, etc., etc. And the next feature would be if I had breakfast on time, or was I, yeah, at what time I had breakfast. So if I had immediately after when I woke up, my mood would be good. And did I get the bus on time, the office bus, the college bus, whatever on time? So all those variations will lead into this feature. So similarly, uh, you can have your own data for which you can do implement this machine learning problem. Also in a business use case, office use case, etc. And now, if you are not happy with the algorithm, the classifier which you have selected, you can always change the classifier. Say, or maybe if you're not happy, or if you want to try out some other algorithms, so how we could do is we can include the random forest classifier as an example, and instead of the decision tree, you just have to change this into I can copy this directly. Random forest classifier, and rest of the code will work as it is. You do not have to change even one line of code. That's how easy it is to switch between the classifiers if you are using sklearn. So similarly, you can also try with the SVM. You can try with SVM with kernel options set as whatever you want. So yeah, I think I have given you some overview on this topic. So yeah, that's it then. Thank you. Bye.